Okay, today we're going to learn about chi-square test for independence. So just looking back, before we get into and do a full example, let's just kind of look back at an example we've done before when talking about independence earlier in the year. So there's all this data about snowmobile use and if you're a member of the environmental club or not. And just looking at the bar graph, um, it seems like if you're a member of the club, the environmental club, you're not going to use snowmobiles as much or own them or use them. All that's going to diminish. So I don't think those two events are independent. I don't think there's so I do think there's an association between those two events. So the question is it plausible there's no association between those variables? And the association in the sample happened by chance alone. And so we'd have to do, a test for chi-square test for independence here to see if there is an association or not. Um, the null is always, so for chi-squared independence, if they're asking about association or independence, you always start the null with the same words. There is no association between blah, 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 blah. In this case, being in the environmental club and using snowmobiles, using or owning snowmobiles at Yellowstone. The alternate is, because in other words, the null, there's nothing going on. There's no association. The alternate is, there is an association. And so those words are almost the start of every chi-squared independence test. I kind of like this. So remember, the null is the null hypothesis. There's nothing happening here. It's null. There's no association between these two variables. They don't have any association. So that's the null. The alternate is there is an association. So now let's look at an actual example and do the full-on test. The Pew Research Center asked 500 randomly selected U.S. adults if they have extended family live nearby. They defined what is nearby and what is extended family. And then respondents were also classified by the region of the country they lived in, like the South, the West, etc. Is there convincing evidence of association between the region of the country and the proportion of extended family for nearby U.S. adults? So right away, just the way they asked this question, is there an association? So we're going to get right into the null. The null is, and then I guess here's the data. It's hard to look at the data and make any decisions right now. We'll have to do some analyzation here. So the null would be, there's nothing going on here. There's no association between extended family and region of the country. The proportion of extended family and the region of the country that you live in. The alternate is there is an association. If you live in certain areas, you might be more prone to having your extended family live near you. You could use, by the way, just a side note, you could use the word independent there. It's okay. I don't usually use it that way, but it's appropriate. And so that's another way to say it. I usually just start, there is no association for the null. There is an association for the alternate. And you can look at this test and see it's not goodness of fit. You got two different variables. We didn't really have that with goodness of fit. We had, distribution of colors for M&Ms or something, right? So it's not like two different variables. Here you have two different variables. You have a 2x2 chart there. That's why a giveaway this was independence. And they talked about association. So let's calculate the proportion in each region who said none. So like if you get your calculator out, not sure what the purpose of this is, but we'll see. Okay, so I'm just going to do it in the calculator here and we'll see what we use this for. So none in the Northeast would be 13 divided by 84. None in the South would be 45 divided by 84. or not by 84, sorry, by 187. That's the total for that one. In the Midwest, it'd be 21 divided by 126, and so forth. So you see, I get different percentages there, and you could do that for all four of those. So those are the percentages. I think they, let's see what they did. They did the same thing I just did, right? And the only reason they might do this, I think, is a question that sometimes is asked is there some evidence that maybe region of the country would, um, affect whether or not your extended family lived close or not? And so just looking at the data, those numbers are all not all even, those percentages. So you're thinking we have some evidence, right? Um, it seems like maybe people in the South and West are more likely to have no extended family nearby. It's kind of sad for the South and West, but that seems to be at least some indication that could be true. But we haven't done the full test, so we don't know if it's enough to say, it's kind of significant or reject the null or not. We don't know that, but there's at least some evidence. If those were all the same proportion there, we think, we don't have much evidence right now, right? But they're not the same. They're quite a bit different. So it could be knowing a person's region of the country might help predict if the person has extended family. So we're in the kind of like maybe stage, but we haven't proved anything yet. So if you want to figure out the expected values, expected counts, I should call them, you do the row total times the column total divided by the table total. So let's do that for the first few here. So let's see if this works or not. Okay, so to figure out none and northeast, the top left expected value. I know the observed counts is 13, but we have to get the expected counts, right? So the row total is 107. Let me do a fraction. I think that'll help. So 107 times the column total for none and northeast is 84. And then divide that by the grand total of 500. So the first expected value there for the top left, northeast, and none would be the observed counts is 13. The expected count is 17.98. Let's do the next one. So south and none. That would be a row is 107 times column is 187 over the grand total, which is 500. So the observed count there is 45. The expected count is 40.018. Let's do the next one. Oh, wow, this is going to take a while, by the way. Wouldn't it be nice if the calculator could do this for us? Oh, it'd be so nice. I think that might happen. Okay, so this one would be, again, 107 because it's in the top row times 126 because it's in the Midwest column divided by the grand total 500. So you could do this for every single item. There's 16 items in lift. It's a 4x4 table. So you'd have to do this formula 16 times. Oof. I guess you can. It's one way of doing it. Another way to do it. They did it like 16 times and got that. Let's just show you how to do it in the calculator. Let's just do that now. Okay, so to do this in the calculator, you have to store a matrix. You can see that there are four different extended family options. None, only a few, some, or all or most. There are four different regions of the country. So a 4x4 matrix is what we need. So hit the key next to number 9. Go to that. It's near the middle. It looks like a big 3x3 matrix, and it's customizable. Type in 4 tab, OK. So we're going to type in the actual numbers, the observed counts here. So 13, 45, oops, sorry, 45, 21, 28, 22, 50, 29, 22, 31, 55, 18, 45. Okay, we're going to store that as, I'm just going to call it family. You can call it whatever you want, actually. Just some context for this problem. So now I have a matrix. If I type in family, it thinks it's this matrix. So I stored it. So control var is the stow key there. So we're ready to do our test. All you need is the matrix in there with the observed counts, and it'll actually calculate all the expected counts in addition to a whole bunch more. So you go to menu, 6, 7, because it's definitely a test. And there it is. It's not goodness of fit. This is a two-way table, two-way test. So chi-squared two-way test. All you put is the observed matrix, which is called family for me, gives me everything. Chi-squared, 10.383. So just to remind you about chi-squared, chi-squared is always skewed right. I like to put this, you don't have to, but usually this peak is somewhere near degrees of freedom minus 1, so that would be about 8-ish. And somewhere out here is our chi-squared value of 10.3883. And we're shading to the right. So that's our shading. If we wanted to, we could do chi-squared CDF with a lower bound of 10.3883, upper bound of infinity, and degrees of freedom is 9. Let's talk about degrees of freedom. So degrees of freedom is a new formula. So when it's a matrix like this, it's going to be the number of columns minus 1 times the number of rows minus 1. So this would be 4 minus 1 is 3. 4 minus 1 is 3. 3 times 3 is 9. That's where they got the 9 there. So it's kind of a weird little formula, but somewhat similar to what we've done in the past. That's how we get our degrees of freedom. And this would give us our p-value. If we typed in our calculator, our p-value is 0.31. That's actually not as low as I thought. I thought we might reject here, but we're not rejecting. So because it's too high of a p-value. So because the p-values of 0.3199 is greater than the alpha level 0.05, we fail to reject it all. We don't have evidence to say that there is an association. So we don't have enough evidence to say that there is. So the expected, get back to expected. So do you see where it says expect matrix? If you hit the var key, all these variables have been stored from our most recent test. So if you go to stat.expect matrix, those are all the expected values. Those first 3 might look familiar because we did those by hand, but you would write those down in your paper, and you really have to write those down to prove the condition. The expected values have to all be at least 5. So to prove that condition, you have to write that down. Also, the other thing that's on there is, see where it says comp matrix? So a very common follow-up question might be, which region or which whatever was the biggest contributor? So you look for the biggest number here, because all these numbers add up to make the chi-squared value at 10.3883. So it looks to me like the biggest number might be this one right here, I think. So that would be south. It's in the second column, and the third one down, south and some. So maybe this number would have been the most, oh, sorry, I was trying to highlight it. That 47 right there is the most surprising number. That contributed the most to the chi-squared value. So again, for the conditions, random sample, it's a random sample of, I forgot how many. So in this case, 500 US adults is what it was. 500 is less than 10% of all US adults. And large counts, you do have to list those somewhere in your paper. Some people write them down in that matrix form, just put an arrow and say all or at least 5. And they are all at least 5, so that's actually good. So if they weren't, we wouldn't pass that condition. Make sure you look at expected, not observed counts there. So we could put the show the first few there. So it's really nice to show the first two, maybe the last one, because we have all the observed and all the expected there. So 13 minus, I think we had 17.98, but they just rounded it, I think, to 18 there. That's why those numbers are slightly different than the ones we had in our calculator. But they just put the first two and the last one. They didn't put all 16 of those. That'd be a lot of work. Usually at that point, we're just grabbing the chi-squared value from the calculator, which was 10.4 something, or 3883. Degrees of freedom was 9, and the p-value was 0.31 something. And so they drew it similar, again, to what we had there. Interpret the p-value. So if they ask you to do that, that's always a tough question. That means assuming the null is true. So assuming there's no association between region of the country and the proportion of extended family who live nearby, there's a 31.6% chance of getting association as strong or stronger than association in the sample by chance alone. What conclusion can you make? Because the alpha level is so high, it's higher than alpha. I mean, the p-value is so high, higher than alpha, we reject the null. There's not convincing evidence of an association between those two variables. We did all that. What do you have to show as far as work in the do section? The chi-squared, degrees of freedom, and the p-value. We like to see a little bit of work for chi-squared, like the first couple fractions and the last one that sometimes is required. It could be. There's one more example for this section. Are people who are prone to sudden anger more likely to develop heart disease? My first guess is, yeah, maybe. If you're kind of prone to anger. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Then categorize each person's anger low as low, moderate, or high based on their test score. They also recorded whether or not they developed coronary heart disease. This classification includes people who had heart attacks and those who needed medical treatment for heart disease. The two-way table summarizes the results of the study. Okay, so they did this. It's hard to look at the table and see too much, but some of those people did get heart disease, but we don't know yet if it's significant or not. Of an association. So again, they're talking about an association, so we know this is a chi-square test for independent. We have two variables, anger level and heart disease. So the null is there's no association between those two variables. The alternate, there is an association. This is called the chi-square test for independence. It was a random sample of over 8,000 people. That's less than 10% of all people with normal blood pressure. And we have to do the test to do this. To do the test, again, you want to do a matrix here. So this would be a 2 by 3 matrix, I think. So go to this command, choose customizable, 2, tab, 3, tab, enter. And it looks like the right size, so I think they did that right. Once you get used to it, this is kind of a fun little test to do. You're just putting in a matrix, the same size as the table. Oh, you should watch while you're typing because you might get off track. 3057 4621. I don't usually watch. Okay, I think that looks right. Okay. Okay, so we're going to store that. So control var and store this as heart or something. So now I'm going to do the test of menu 6.7, and it's called two-way test, two-way table. and heart. Now, once I've done the test, you can look at, it won't work until you do that, but now if you var and go to expect matrix, it's got all the expected values there for those 6 categories. So then you can write those down, and those are the expected values we just got in our calculator, I believe. Let's just double check. 69.7, 106, yeah, all the same ones. Okay, so we've shown all those are at least 5, all the expected values. Most of them are quite a bit above 5. One of them is close. Don't round those. Fine to have decimals, no problem. We expect decimals there. Do the first couple, maybe the last one, using your expected values and your observed counts. That's good to do. And definitely write down the chi-squared value, which again was from our test was 16.07. Our p-value is 0.0003. That's very small, right? At the 10% level, we know we're rejecting here. P-value was 2 because number of rows, 2 minus 1. Number of columns, 3 minus 1. So 1 times 2 is 2. They drew it, so this is interesting. When it's degrees of freedom 2, you could draw it like this. It wouldn't be bad if you drew it like this, right? I mean, it's not a problem. But they say it'd almost be falling. Degrees of freedom is so small, it's almost just falling down there. But we're okay however you draw that. As long as it's skewed right. Got to be skewed right. Chi-squared, those were the values we had from the calculator. That's our conclusion. Because the p-value is so small, less than the alpha, we reject the null. There is convincing evidence of association between those two variables. Yeah, that's true. So sometimes they put that number in scientific notation when it's really small. Just be on the lookout for that. Sometimes that might mess you up, but it's going to be a number between 0 and 1. It's definitely not going to be 3. 300%, that's not a chance there, really. Okay, that is the lesson for today.